Now for this question then, we're given that fx equals 5x squared minus 4x to the power 3 over 2 minus 6, where x is greater than or equals 0. We're also told that there's a root that lies in the interval between 1.6 and 1.8. And we've got to work out what that root is by linear interpolation. So to do something like this, what do we do? Well, first of all, we need to work out what kind of value we get when we substitute 1.6 and 1.8 into here. So we'll do that first. We'll just work out what f of 1.6 is. So if you substitute 1.6 into here, you should find you get a negative value, minus 1.295430, and so on. Now if there's to be a root in between 1.6 and 1.8, I'd now hope that I get a change in sign, I get a positive value when I work out f of 1.8. If I don't, I'm in trouble. So put that in there, 1.8 into that, and we do get a positive value. In fact, we get 0.540186 and so on. So at this point, it's a good idea to draw a little sketch. So I'm just going to do a sketch then of the graph, the kind of results that we've got so far. So we know that there's a root then somewhere between 1.6 and 1.8. Now this is not drawn to scale. It doesn't really matter so much about that. But we know that at 1.6 we've got a negative value. We'll put it down here. And that value is, at this point here, minus 1.29, blah, 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 and so on. And we've got up here a positive value, okay, at 0.54 and so on. So if I was to draw a line between those two, this is our root, alpha. And we're using linear interpolation, so we're expecting to assume that the graph is linear through here. It's not, but that's what we're basically doing. So how do I get alpha at this point here? Well, we look at triangles, similar triangles. Look at this triangle. It is similar to essentially this triangle over here. So we just need to compare lengths. So if we start off, we can compare, for instance, this length here with the equivalent length on this triangle, which is this one. So this length will be alpha minus 1.6. So we start with alpha minus 1.6 divided by, compared with, if you like, this length here, 1.8 minus alpha. So 1.8 minus alpha. Now if we compared this length from this big triangle with this length from the small triangle, then I need to get another equivalent comparison. And we're going to go for this length here compared with this length here. So when we're comparing this length, we just take the positive value here. So the length will be 1.295430 and so on, that many units. And we compare it now with this length, which is the 0.540186 and so on. So all we need to do now is just solve this equation for alpha. And obviously there's many ways that you could do this. What I'm going to do is multiply through by 1.8 minus alpha and also do this division here. Now if you do this division, what we end up with is a value of 2.39811 and so on, and that is now multiplied by 1.8 minus alpha. So if we expand the bracket, 2.39811 multiplied by the 1.8, it gives us 4.316610 and so on. And then we've got to multiply that with the minus alpha, so we end up with minus 2.39 0.811 and so on, and that is alpha. So we could add this term to both sides and add 1.6 to both sides. If we do that, then alpha plus the 2.39811 alpha gives us a total of 3.39811 and so on alpha. And if we add 1.6 to this value here, we end up with 5.916610 and so on. So finally, to get alpha, we just need to divide this by 3.39811. And if you do that, let's just come down here, you find that alpha equals 1.74114 and so on. And if we give this to 3 decimal places, which we're expected to do, then alpha equals 1.741 to 3 decimal places. And you can see that looks a sensible result, somewhere between the 1.6 and the 1.8. Okay, well there you go. That's linear interpolation.